Welcome to my channel. Your tutor Mariam is here. It's the 27th video of Introductory Physics 1 and the 8th video. I'm going to talk about the motion in 2 and 3 dimensions. It's a part 3 of solving the example of projectile motion. So I'm going to solve another example about the projectile motion, which I find it interesting. If you like my video, hit the subscribe button and like for more. You ready? Let's get started. In this problem, I need to find the angle between aircraft and ship, and for the second part, I need to find the velocity when the object reaches to ship. Let's see how I can solve it. So for the first part, we all know that theta is equal to y over x, right? And then based on the projectile motion, my y gonna be half of g t squared plus v sine theta, and then for the x I have v cosine theta t, right? So if I simplify the problem, it's like I have a particle here and it goes to C, right here. And then I'm looking for the angle, which is theta. So if you look at the equation for x and y, you see I have two unknown parameters. It's going to be t, theta, and then t here. For this guy right here is going to be phi and t, right? So my point here is let's not use the same angle I'm looking for. Like instead of writing down the equation of motion at this point, like I'm gonna call it as 1, let's write down the equation of motion for position 2. So it's gonna be for position 1, and let me write it down again for position 2. So for position 2, I still have the same parameter like g t squared plus v t sine phi. I'm going to change the angle and I explain you why. And then for x, I'm going to go with cosine phi t. So why I'm saying phi? Because when the particle reach to C, like here, then the angle between the object and C gonna be 0. So if I choose the phi right here, this angle gonna be 0. And then I know the angle right here, right? The other parameter you might wonder is velocity here, right? But remember, for the projectile motion, velocity in x-axis gonna be constant. So my velocity here, v, which is equal to 40, is the same at this point. So this guy also gonna be 40. Because there is no acceleration applied in the x-axis. So v at the highest point and at the lowest point gonna be 40. I explained it in my previous videos, and also I'm gonna put the link below. Now let's substitute the value for position 2. I'm gonna take my origin at the point particle dropped. So this gonna be my origin right here. So this gonna be origin. And then my y here gonna be minus 10 because I'm looking at the position 2, and if my origin is here, then this distance gonna be negative, right? So it's gonna be minus 10, and then half of, I'm gonna approximate g as 10. I don't know what is t, I'm looking for that. And then my v gonna be 40. I don't know t. And then sine, and my angle gonna be 0. So this part gonna be 0 because the sine 0 gonna be 0. And then I have minus 100 minus 5 t squared, and my t equal to 4.4 seconds. That's the second. symbol for time. And then my x gonna be 40 times cosine 0 times 4.4. Cosine 0 gonna be 1, so my answer is 9. Now I can find the angle, so theta gonna be tangent of y is gonna be minus 100 over 9. That is equal to minus 11.1. And this is gonna be my final answer. And the reason I'm saying this is minus because tangent minus theta is equal to minus tangent theta. And this is what you know in math. Now let's look at the second part. So for the velocity, when it's reached to its shape, we know the angle here is gonna be 0 again. So we are not working with phi, we're working with theta. Now my v is equal to v cosine theta times t. V is 40 cosine 0, and I've already found time, which is 4.4, and then cosine 0 gonna be 1, and then answer gonna be 1.6. This is my v in x direction. For the y direction, I have minus gt plus v sine theta t. So I'm gonna say my g is approximately 10, my time is 4.4, and then plus my v gonna be 40 again, sine 0, and time is gonna be 4.4. So sine 0 is gonna be 0, and then my velocity gonna be 44. And then the last part is put them all together. So my v gonna be vx. I'm gonna write it in the unit vector, vi, and then it's gonna be v in y direction. And then for the x direction, I found 176 I, and then for the y direction, it's gonna be 44 j. And that's going to be my final answer. In the next video, I'm going to solve more examples. If you like my video, hit the like button, and I'll see you in the next video.